first graders, I'm Miss Ball. I'm a teacher at Spokane Public Schools, and I'm here to do some more math with you again today. We are going to work on two standards today. The first standard says, I can mentally find 10 less than a given number. And the second standard says, I can use place value to add two two-digit numbers. Now, a two-digit number, remember, means that you have two numbers that make up that total number. So there's two, this 2 represents 2 tens, that's the first digit, and the 4 represents 4 ones, that's the second digit. So the number 24 is made up of 2 digits. So our goal today is to be able to add two two-digit numbers together. So we're going to start with a little warm-up, and I'm going to remind you of the model we're going to use today to represent tens and ones. So I have bundles and sticks. So bundles means that there's 10 sticks inside of this, and so we would call this a 10. So this would be 10, 20, 30. And then our sticks are representing our ones, just single sticks. So this would be 33. And the way that I can draw that out on paper looks like this. So this represents each bundle, 10, 20, 30. That's my bundle. And then the dots represent my sticks. So 1 stick, 2 sticks, 3 sticks. This number would show the number 33, which is a two-digit number. So let's work on some more quickly. Go ahead and shout the number out when you see it. How many do you see? Now, before I tell you the answer, I want you to show you something else. The way that I organize my ones is helpful for you to be able to see the number quickly. And when you organize your models, when you're solving problems, you might want to think about that as well. It's mathematicians need to be precise, which means accurate, so that they can easily see what numbers they're trying to solve for. So this is 20. We see 2 bundles. And then here you can see I have a group of 5 and a group of 4 next to it. So I set it up similar to a 10 frame. You can easily see that the 1 dot is missing. So that number would be 29. All right, we're going to move a little faster. Here we go. Shout it out. How many do you see? 55. All right, how many do you see? Ooh, look at this. Now we have a number, and then we need to take away a 10. So picture taking away that 10. What would we get? 32. Try another one. How many? Good. So we have 21. Take away the 10, and we have 11. All right, sometimes this one can be tricky. If we have 13, we take away that 10. What's left? 3. All right, let's take away the model and just try it with numbers. See if you can picture that model in your mind if you need to. 64 minus 10. So you can picture those 6 tens and the 4 ones, and if we take one of those 6 tens away, we get 54. All right, 28 minus 10. 18. You got it. Awesome job, first graders. Let's move on to our problem for today. So this would be when you need to use a piece of paper and a pencil if you want to follow along with us and draw your own model. I am going to give you some time during the video to solve it on a piece of paper if you need to, or if you have a whiteboard, you could use that. If you don't have either one of those, don't worry about it. You can follow along with us. And at the end of the video today, I'm going to leave you with a problem at the end to try to solve on your own. So you can always do it later if you need to with that one. So here's our problem today. It says John had 45 toy cars. He got 16 more for his birthday. How many does he have now? So I'm going to wait while you draw yourself a model and think about using those place value strategies to draw out what's happening and solve for the answer. How many toy cars does he have now? Go ahead and get started. Okay, let's take a look at some ways you may have solved this problem. Maybe you can connect with one of my friends to say, hey, I solved that problem just like that. So this is Brown Bear, and Brown Bear drew himself a model that looks like this. So Brown Bear's model says, I have 45 toy cars plus 16 more. What would that be altogether? And Brown Bear first added the tens together. So 10, 20, 30, 40, 50. Think about how different that is than if you drew 45 by ones all across your paper and had to count all those up. It's a little bit, well, quite a bit faster to count them by tens using place value. So 10, 20, 30, 40, 50. And then Brown Bear saw some ones left over, so he counted those up. 51, 52, 53, 54, 55. 56, 57, 58, 59, 60, and 61. So Brown Bear knew that John had 61 toy cars after he got those 16 for his birthday. Let's take a look at what Cotton did. So Cotton solved this problem also using place value strategies, but thought of it in a little different way. So let's see, maybe you did it like this. So here we have 45 and 16. So Cotton took this 45 and this 16 and made another 10. So it goes 10, 20, 30, 40, 50, 60, 61. So out of that 45 and that 16, Cotton was able to make another 10, which made it even faster to be able to count that and didn't have to count so many by ones. 10, 20, 30, 40. Took those two fives to make 50, and one more 10 is 60. And then 1, 61. Maybe you solved it like Cotton, or maybe you solved it like Ellie. Ellie likes to use an empty number line. So Ellie took this empty number line, drew out the line, and put her starting point of 45, and then took apart the 16 into a 10, a 5, and a 1, and made those hops on the number line. So 45 plus 10 got Ellie to 55. And then 55 plus 5 more got Ellie to 60. And then 1 more to 61. So Ellie got the same answer as Cotton and Brown Bear, but took hops on an empty number line instead. So we had 10 plus 5 is 15, plus 1 more is 16. So 45 plus 16 is 61. Did you solve it just like Cotton or Ellie or Brown Bear? Maybe you did. Maybe you solved it another way. There are many different ways you could have solved that problem. So you do the way that works for you. But I do want to challenge you to try to use place value strategies to add two-digit numbers together. So I'm going to leave you today with a problem. See if you can solve this today with your grown-up or with somebody nearby. And you can challenge yourself to try a strategy similar to Brown Bear or Cotton or Ellie. Maybe you want to try all three strategies to see if you can do them. So here is your last problem for today. I want to see if you can solve 68 plus 24. All right, good luck, friends. I wish you well, and I hope to see you again soon.
Hi, mathematicians. This is Mrs. Yahara with Spokane Public Schools, and I'm looking for a few first graders to do a little math with today. However, if you are a mathematician and not in first grade, oh, by all means, please stay and join us. You might want a piece of paper and a pencil to help work through some of your math thinking, but you don't need it. And instead, you might want to try this mentally. It's also nice to have someone in your house kind of close by that you can talk to about some of this math. And if they're not close by, you might want to let them know you could be asking them a few questions in the near future about math. Are you ready to get started? We're going to be working on solving addition problems with 3 whole numbers, and the sum will be less than or equal to 20. So this means that I'm going to be solving an equation that has 3 addends, and our target number is 12. So our equation might look something like this, where we have a number plus a number plus a number to make the number 12. Now, in first grade, we work really hard on doubles, and you might already know right after that, in a snap, you might already be thinking Well, I already know, Mrs. Yuhara, that 6 plus 6 is the same as 12. And I would say, right on. But let's take a look at our equation, at our number sentence. It's saying that it wants us to try to find 3 numbers that when we put them together make 12. So plus plus equals 12. And this one only has 2. So we're going to need to do a little bit of stretching. We have to stretch our brain to see if we can come up with 3 addends to make 12. Now, behind this purple paper, I have 3 10 frames, and they have some dots on them. And when you add all the dots together, they make 12. So why don't now I want you to be thinking about those 10 frames, and what could those 10 frames be? What could they look like? There's a lot of possibilities, you're right. So I think what I'll do to kind of help you out is I'm going to show you the first 10 frame. And the first 10 frame, what do you see? Yeah, 5 on top, 1 on the bottom. So altogether we see 6 dots. Now, that's pretty close here. Start with our 6. So I know I'm going to have 6, and I'm looking for 2 more addends to make 12. So what goes with 6 to make 12? Do you have any ideas? This is where you might be wanting to talk to someone next to you, maybe telling that other person in your house, hey, looking for some ideas. If I have 6, what 2 other numbers could I put with it to make 12? Turn and talk for a moment. Work it out. Sometimes using our fingers is really helpful. Sometimes drawing pictures is helpful. Maybe you have a pile of Cheerios. Maybe you're working through that. Try not to eat them all. Remember, you need 12. I have 6. What could I put with this? Oh, yeah, I do think I am hearing someone say, well, what if I had 5 and 1? If I put 5 and 1 with 6, would that make 12? Could that be an option? Well, 5 plus 1 is 6, and we already know 6 plus 6 is 12. So sure, that could be an idea. Absolutely. Why don't we take a look at the next 10 frame to see what it is? Okay. Oh, how many do you see on there? Yep, I see it too. I see 4. Now, I don't know. Sometimes what's really cool about 10 frames is you can kind of move them around. So if I take this 10 frame off and I just kind of pretend like those dots are moving up into this other one, do you see what I see? Yeah, I see it too. I see a 10 frame, a full 10 frame. Look at that. So we know 6 plus 4 at least makes 10. I'm going to erase this one because we know 5 plus 1 isn't one of the options, although that was some great thinking. And even though maybe one of the solutions that you came up with when you were talking with people around you isn't the one that's on our 10 frames today, does that make it wrong? No, it just means there's another way. So we know that 4 is one of them, and we know that 6 plus 4 makes 10. So why do I need to go with 10 to make 12? Oh, I already know. People are nailing it right now. People are saying 10, 11, 12. We need 2 more. And the prediction is that we have a 10 frame with 2 dots under here. Are you ready to check it out? Yep. So we have 10 plus 4 plus 2 is the same as 12. You did it. We were working to solve addition problems today with 3 addends, and you did it. Our target number was 12, and we came up with 6, 4, and 2, that when you add them together, they total the sum of 12. Can you think of other math problems with a different target number? Maybe you and the people in your house could think of how many, if you have 3 sums to make 10, or 3 sums to make 8, 3 sums to make 18. Play with that. See what you come up with. How many different ways can you come up with the way to make your target number? It's been fun doing math today with you, mathematicians. Until next time.